Hey everybody, this is Larry. This is day 9 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Today we have 1382, balance a binary search tree. Oh yeah, as you can tell, I went snowboarding today. Hope you like the intro. I don't know, it's my first one doing it this way just because it's such a unique thing. I mean, I stopped snowboarding for like 8 years. The last time I went snowboarding was 8 years. And even then, I wasn't really going. I just went like with friends. So the last time I really snowboarded was maybe like 12, 13 years ago. So I'm very glad that like, you can, not super embarrassing. I need to kind of clean up the form. I need to do different things and do switch and stuff like that. But yeah, just kind of, and that video, of course, was the safest video in the day because I tried to kind of keep it safe. They said that like part of it is a double, not double, a regular diamond, but I don't know, maybe I don't know. Northeast grading, I guess, and everything is just so short, so who knows anymore. But yeah, let's take a look at today's problem. We have 1382 balance a binary search tree. Given a root of a binary search tree, return a balanced binary search tree with the same node value. If there are more than one answer, return any of them. Binary search tree of every node never differs by more than one. What do they want us to do here? Did we do? Oh, I guess that's fine. I think that my confusion initially is, well, maybe it's still, no, just the same node values. Okay, that's why. Because I thought we had to, balance the search tree one step at a time, which of course is a whole different thing. I mean, not impossible, but like, definitely not a medium, definitely tricky. And I don't even know if it's hard in a difficulty sense, because it is just like a textbook thing. So if you knew it, then you know it. If you don't, then it's hard, right? And there are a lot of edge cases depending on what, which kind of balanced binary search tree you use. But this particular one, it just has to be the same node value. So it's not even that. I mean, I think the straightforward way, of course, is just by divide and conquer, right? First, we're going to traverse the tree. So maybe we have a traverse now to get all the values, right? And here, maybe actually I'll call it in order traversal. just in order. So then we can say, visited maybe. And then here we have, if node is none, then we return. Otherwise, then visited, we append that value. Right? I assume the values are unique. Actually, I was wrong. But I guess it doesn't. I guess actually it doesn't matter because we're going to do it not on the values. Initially, I was, but then I was like, that doesn't matter, right? Unless there is like some different differentiation on the thing. But yeah. So for this to be actually in order, of course, you have to do left, current, right? Something like that. And then now we can just do a divide and conquer on the visited array, right? So then now maybe we could construct tree, maybe? I don't know. Naming things is tough. But yeah. And the idea here is that we want to return a new tree node with some stuff. We want to say, I guess there's two ways to write it. I'm just going to do left, right, and these are bounds on the on this array inclusively, right? And you want to write that, explicitly because sometimes it can be tricky and you get off by once. And the reason why we, you can also do the sub array, which is technically more functional, but I don't know. It's okay. Because this is going to be way more efficient because you don't have to copy memory all the time. Which, even though technically it just makes it n log n, but it's fine. Or n log n space, because this is already going to be... No, wait. No, it's not n log n space. It's just all of n time and all of n space, right? We just kind of construct the tree differently. Yeah. So then now maybe we can say, so we're going to... If left is greater than right, then we just return none. Otherwise, then now we can construct tree, maybe left node, construct tree, starting from left to, okay, so mid is going to be, you go to left plus right dot by 2. I think that's fine, right? So then now this is going to be mid minus 1, right? Node is going to be construct tree mid plus 1, right? And of course the current node, it's going to be the one on mid. What was that? The value first. The value, which is going to be visited of mid. And then left is going to be left node, right? And that's basically it. And then we just construct tree from... Why do I have node? I don't even use this. I think it's just like, maybe I don't know what I was thinking, honestly. Maybe just like force of habit for some reason. But yeah, we construct tree from 0 to n minus 1, right? Where n is equal to length of visited. And this is inclusive, of course. And yeah, that looks okay, right? Yeah, pretty straightforward. Only 17 cases a little bit weird, but maybe not. I mean, this is not a thing. I think the biggest thing is just reading the problem correctly, because I was honestly thinking never to balance a tree, and that would be way just difficult, like I already said. This is in order and thus linear time and linear space, because your stack size could be linear. For example, you have even example 1 where on the left side, you just have a lot of stack space, right? Here though, it's gonna be log n stack. But so actually only at most, I mean, it's gonna be linear space just because you have to construct a node for each node, each value, and yeah, and linear time because every node gets visited once, right? Yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. Hope you liked the intro. I don't go out much anymore. I'm always so tired. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.